we have Dr. Armin Strobel at StrobelTEK, and they are focusing on the future of unmanned aerial systems. And Dr. Strobel has worked in the field of unmanned aerial systems since 2003, so almost 20 years. It seems to be a very exciting topic and a lot of expertise there. And while at the Technical University of Darmstadt in Germany as a PhD candidate, he was responsible for the development of a very stable multi-rotor with a PhD focus on swarming UAVs. Most recently, he's working on combining AI with the fully autonomous UAS for multitude of applications in his venture, StrobelTEK. Dr. Strobel today will talk about remote operation and the way forwards to remote management. Armin, I look forward to hearing what you have to say today. Enjoy the session.
Thank you, Florian, for the nice introduction. I do always also the same thought. Since time changed a bit.
Armin, I think you are muted. We can't hear you.
I should be fine.
It's a classic.
Can you hear me now?
All right, all good.
Okay, you can hear me. Okay. It seems so, at least. Okay, if somebody can't hear me, then
it was only us here because we muted ourselves. So it's not you. It's all good. Part of the technology gap.
No problem. I'm hearing myself. That's kind of irritating right now. But thank you for the introduction, Florian. It was really nice. I'm also actually I'm doing it myself in the process of the presentation myself wrong. Then please excuse me. We're not supposed to say unmanned anymore, so we say unoccupied or uncrewed or anything in that way. So if I'm saying it wrong, and I probably will use most of the time the abbreviations UAVs and UAS, that makes it easy. Yeah, I think I'm just gonna jump into the presentation and share that with you. Oops, no, that was the wrong thing. Just give me a second. Yeah, so you should see now my desktop and now the slideshow. Okay. The camera should be off. Oh, it doesn't matter. You can see my slide deck?
We can see it.
Okay, perfect. Good. Then just a quick, Florian gave already a quick introduction to myself, but I want to put a bit more emphasis on things what I have done in the past, which are really relevant to the presentation. Then I will go quickly in remote operations in general, and actually also emphasizing the transition in a remote management actually. Then I will go really specifically into the remote operations with our Sprinter system, and very specifically into that, and also raise some possible applications and examples of the processing or automatization and use of AI algorithms, where I'm sometimes shy away to use that term AI because it's really, I think, often too much used for actually relative simple things. So you might not hear as often AI in this presentation as you might be used, but some people would probably call it AI. And then also then we will open it for questions. So quickly, aerospace engineering, swarming of UAVs, that Florian mentioned that already. And also in one part, what I did in Darmstadt, where I was doing my PhD, I joined the RoboCup rescue team of Darmstadt, which is now called Hector. And if you're in the robotic world and working with Rust, you might have heard about that team. Also on the side, as part of my PhD, we get sometimes asked to do some complex math stuff. And we have done actually some big data projects with Lufthansa and DFS, which is the equivalent to NAV Canada in Germany. Also then here in Canada, when I came in 2012 to Canada, so I'm 10 years now in Canada. I worked on different projects, among that the Autonomous Ocean Systems Lab, on a Sea Dragon, flying drones, also regulated. That Sea Dragon is a surface craft which has a really unusual shape, and I did basically the control from the low-level control that it even goes straight, which was quite a challenge actually, to up to the controls which actually automatically goes around an iceberg and actually automatically creates a 3D point cloud of the iceberg above water and underwater. And also one additional thing, I mean, that the company won that award, the Akada Innovation Leader Award in 2020. But since the company is so small, I thought I'm mentioning that here too. So remote operations, I mean, the problem is sometimes that people misunderstand possibly remote operations with the remotely operated drones, which are flying. So you have a remote control, and you're controlling the drone, and since you have the drone is a different position, you have a radio link, you're operating remotely. There can be also remote operations, but the things what I'm here talking, and was probably all the following people also in that part of the remote operations, they understand more the more distant part, that you're not really directly in the view of the thing, or that you even, if you're thinking on ROVs, that they're not necessarily get controlled from the ship where they're deployed from, that they might be actually controlled in a control center, completely different location on the other end of the world. And that's where StrobelTEK comes actually in, where we have actually similar thing. Our system can be controlled from anywhere in the world as long as you have communication and power to our system, and that can be done. So often remote operations includes either we have sensors or actuators, and also some art of automatization, and there it comes with the remote management. Depending on how much automatization you have, you might not even need to control it manually in some way. You can actually define objectives in a relative abstract way, or you actually create just trigger some remote event which gets automatically automated, which actually provides you on the end, possibly actually even just with a report what you're looking for, and alerts you whenever it's necessary to take a human action. So there's a wide bandwidth where you manually can control what you see on the right or on the left side on the picture, which might could the remote management system look like, where nobody's actually sitting there. They get all just alerts on their phones when they need to be available for that. Similar, and I mean, there's different sensors and actuators, as I was before mentioning it, and there is a lot of diversity actually. And I mean, what you're probably used to is the stationary sensors, some valve position sensors, some pressure sensors, some temperature sensors. They're mounted, fixed on a location, and you have possibly a remote management operation center where you get those values shown. And also you have, well, for sure, some automatization in the background, which does some keep some temperatures in a certain range, and does that operate. A really interesting gadget when once you get sensors which are mounted or part of mobile robots. They can be land-based robots, like on top what you see the Spot robot walking from Boston Dynamics, or our system, or ROVs, or other autonomous underwater vehicles. The advantage of those is that they can provide sensor information from different locations, which already creates then, in some cases, a 3D point cloud or distributed values. And with that, we can already do, in many cases, lots of more information than actually having a sensor on a specific spot. It's similar to a camera where you can get every pixel more, but if you get actually to move a camera around, you can actually create a really complex 3D model with photogrammetry, for example, or with a laser scanner, you can create also a 3D point cloud. So remote operations, what is the motivation behind it? Yes, I mean, we always want to improve processes, our lives in general, actually better. And so remote operations is the same thing. I mean, we're creating better awareness of the status of oil rig possibly, or other in general objectives. I mean, I'm trying to put it now into an oil rig example, but it also, if once you know better what's going on, what is the status of your entity, then you can plan much better. That means also that you have possibly less downtime because you can coordinate maintenance actions because you know, okay, I have to change or take care of those rusty spots at that within that time frame. While I have to shut down, but I can also do other things at the same time, which you might have would have sequentially done. You do it in the same time because you know all that in advance, and also the whole thing gets more safer. Not just because you have less people, because also because you have a better awareness. And I mean, less people, I mean, in that case, you need to put less people on the oil rig, which is not just a safety advantage, it's also saving you lots of money because those people need to be trained to be on that rig, need to be transported. You have to have people again to transport those people. So it's a set of things. That said, and I'm put it by intention, not necessarily on that slide, is actually remote operations are also seen for some people a bit, yes, I don't want to say threat, but it's kind of, they look really with a different eye than I'm looking and possibly you are looking too at it, and more suspicious. And I can understand that partially because automatization has two things. I mean, one, it has to be trustworthy, so it has to be that it does really the job what it's supposed to do and not do some unexpected behavior which can be leading to really unsafe conditions or playing out to wrong information. And that's also what I have experienced, not in the oil and gas field, but in other fields, that people fear that their job gets lost. And to be honest, I mean, if you talk with the people in general more longer about that whole thing, people often realize that's actually not the case. Their job gets usually better, better conditions, working times, and they actually usually get also transferred to more higher paying jobs than actually, and that's what you see in less industrialized and highly automated societies where, for example, Japan, or also where I'm coming from, Germany, there's lots of thing production is really highly automated. And Germany, for example, has a 3% unemployment rate. So it's not, by no means does mean that the stuff like this needs to be feared actually. I have here a slide, and I just should highlight, yes, you have remote operations where you can get data from and you can look at it and but also a really important part on the whole thing is what are you going to do with that data. And there's sometimes just relative simple things. So you have on the left side a thermal image, on the top side you have a film on the left side top, you have a 3D model of the thing. Them themselves, yeah, the thermal image is often really interesting because you can't see with your eye really what the temperature of a surface is. But it's really interesting. You can already see there's different spots where it's hotter and where it's colder. And if you have some experience, you know, okay, in that spot it should be that hot, but in that spot it shouldn't be that hot. Other spots it shouldn't be hot. 3D model is a bit different because we perceive usually with two eyes our environment as a 3D environment. But when it gets really interesting is actually when we overlay those information. What you see in the bottom here, it's not a 3D model example, and right, is overlaid a normal image overlaid with a thermal image actually. And that's not necessarily the best example, but I mean, here you can actually see what driving style actually possibly the person had, or how long they ago did put the car there and stuff like this, which you would have not out of the normal picture scene, but also not necessarily out of the thermal image because you can't really necessarily read the license plate and understand. That's not a good example because you're spying on actually employees, but or possibly employees. but that shows, that's a good example to show what information you can gain when you're combining multiple different data together in one frame or in one time scale, and you're gaining information. On the top, you see actually, even if you're not combining data, if you can actually use some formal data information where you say, okay, we can monitor change, or we can also look into training neural networks, which actually can identify objects in that case. On the top, you see actually an actual picture. What I've done is a formal image on the left side, left part. So you see the black part here, what you see here. The left image is the unprocessed image. The right one is the processed image. And the left one is, you see actually you see a car there, you see a dog and a person. And the car you can identify in the left image quite well. The dog, not so much, and the person a bit better. Whereas in the right side, everything else is blocked out, and you see actually the car. I see a white spot and the black spot. Similar to the dog, it's also relative bright and right and left. That's already some processing done. And with that processing, you based on the size and some other information, you can actually say, okay, that's actually a person or a car or something like this. So it's already, that information is really, yes, your remote operations is great, but that gives you the ability to have another sensor to actually integrate into your AI or your automatization to actually gain even much more information based on that information. So now we're getting actually into our system. To gain those information, I mean, if you have to remotely control and send somebody onto the rig, that doesn't really make sense. If you have want to collect every day, let's say, information. It does make sense if you have it once a year or something like this. Then a system like ours doesn't really make sense to deploy and have installed and all that stuff. So it might, that really depends on the example. But the cool thing is on our system, you can relatively easy collect multitudes of different data and also and can also monitor changes to it. So the advantage of our system over most other drone systems is that it has a docking station, which is really compact. That's actually the most compact docking station you can get for a given weight of the drone. So the drone takes off from our docking station, does survey the area, and comes back automatically. So there's no real interaction necessary. So we call that full autonomy because it does launch, does execute the mission, recover itself, and replenish it. Also, that part I didn't mention. It does get recharged automatically, and it has different applications for that. And also, we have tested it really excessively here in Newfoundland. I had it pretty much for one winter, the whole docking station for the whole winter on the back of my car, and did multiple times takeoff and docking from there. So just before, I mean, I talk now a lot about the drone system, but I think the video shows you much more. We will also in the end show the video of, we'll share a list with you of the videos links so that you can actually have a look again at the videos, or if they're not shown really proper, that you can actually have a look at them afterwards. So you see actually the drone took off from the docking station in the back of the car, but it can be also stationary. I think I have a video also following that stationary application. We will probably cut that short. It flies around. You see on the top left the video stream from the drone. I kind of cut it by intention really short, the whole thing. And we have also no object identification on included in this. This just shows you actually the operations of the drone, that it automatically takes off. When you saw me in the frame, I wasn't even in the car or controlling in any way. I just triggered the whole thing taking off, and it does automatically does its mission. And also what you now see actually land in the docking station automatically. And again, the docking station retracts, and the drone gets already charged actually in that moment. And the cool thing is it's really compact, and also the whole thing is really robust. So actually the lid is not opening as fast as it could, but we have it really powerful actually, the lid. So, okay. here is the next video. It's basically the same thing, taking off from a stationary, so a fixed oil rig will be certainly the same thing. I'm not going to play that video to the end, but it will be in the links together where you can see actually. So what I already mentioned is our Sprinter system. What we have at the moment is the 200 version. We're planning on possibly building a bigger version down the road because we have some requirements where we want to have more payload capacity to put more different sensors on board, and also to possibly actually have a longer endurance to actually provide better situational awareness of things. And so the one thing is the Sprinter UAS. That means that that one gets bigger, and it's based on a ducted fan, which has also another advantage actually, which I haven't mentioned. Due to that is every rotating object enclosed, it's very intrinsically safe actually. So even if you touch the drone itself, there's no threat to anybody. Yes, but you shouldn't grab with your fingers inside the duct necessarily. That's definitely not a good idea. But compared to any other drone, it's a very safe object. Yes, and the docking station itself does take care of all the operations and itself what it needs to do. So the deployment of the drone does automatically deploy the funnel to recover the thing, and is really, as I mentioned before, really compact, and that makes it for lots of applications really. So, I already did think so. Mentioned that we have working on different sizes of drones. That slide is a bit older. We had some interest in making the drone even smaller, but that will be actually. I don't think in the near future we want actually to integrate more payload capacity and possibly actually different propulsion system. Whereas we have looked into internal combustion engines, but since the technology progresses quite quickly, we might actually stay with batteries or even transfer to, or in some cases, to fuel cell propulsion, which will be really exciting. Again, to mention, the lid opens relative quick in 4 seconds. That means also our drone is in 4 seconds in the air. That means our drone is always on standby. So if you need quick response in any way, we can open have the drone in within 4 seconds in the air. The docking station itself is really weatherproof to most extent. I mean, certainly if you have wave swapping over it, it will be not in that stage, but we're certainly actually looking also at making it really watertight in itself. There's some more minimal maintenance required. We kept the whole system as least complex as possible, and as far as we know, except cleaning some contacts every now and then, which is really once a year maybe, or even every twice a year when you anyway general maintenance, we don't really need anything maintenance. So here I would get to get a bit more depth in view of the whole system. So what you see actually usually is just the drone itself and the docking station. Much more of the system you don't see. We have integrated quite a few things already into the docking station. For example, there's already GPS integrated in the docking station with a GPS antenna also, that the drone always knows where the docking station is located, and it can come back in case it's for mobile applications. Or even for static applications. You want to have a relative position really precise, and for that you need actually have on the docking station or anywhere else additional GPS antenna. So the docking station has also a computer included and has multiple different interfaces. Whereas we have integrated so far 2 parts of it. One is for the remote operations, so you can actually remotely log in from your computer, which I'm doing regularly actually, into the docking station computer, and actually control from there the drone. That can be via VPN from anywhere in the world, or what I'm doing actually all the time actually right now is actually locally. And then offline operations above, which with human machine interface, where you actually it's basically the same, just locally controlled from directly hooked up from a computer. Where we towards working, and that's where remote management actually even more gets in, is that we're actually offering possibly drone as a service, so that actually the user is not anymore defining what objectives he wants or points of view he wants to look at it, or anything like this. I mean, he still has a fallback where he can do that, but an end effect is he schedules some tasks in a web interface. They get completed, and the data will be processed, and you get a notification via email or via text or in the app, and provides you with the information you're looking actually for. Just a quick history of our system, and I'm going really quick because I mean I've counted it at some point, and there was over 25 prototypes. Here's just a fraction of the prototype shown, but it gives you a timeline from 2015, where the first really crude prototype was flying the first time, to 2020 to now, actually, basically, where we have actually even not the newest docking station is not in there, more compact, more dynamization, and all that stuff. So there's in between the drones, for example, were 100% 3D printed, which allowed us to iterate really quick, and that's why we have so many prototypes actually, because we literally were able to build and test within 1 week one prototype, modify it in the next week, and have flying again. So we were able to really iterate quickly and modify things which didn't work that well to do the next stage. Later, we interchanged those parts where we realized, okay, they are pretty much going to stay like this with composite parts. So we even use their additive manufacturing, so 3D printing and CNC, computer numeric controlled machines, to actually machine molds for those parts, and then building really extremely lightweight and strong composite parts, carbon fiber and glass fiber. Also, we tested it quite extensively, what I mentioned before. Lots of outdoor testing, lots of indoor testing in test stands, where we actually right now heading towards is building up 24/7 test stands, so that actually the drone can operate outside in a safe environment 24/7 to actually identify really all the issues, the weather limitations, all that other stuff. But we have identified quite some things already. For example, we have demonstrated a few times docking in gusty winds up to 50 kilometers per hour, which we are actually really proud of. Don't nail me down on that. I'm not going to sign off that because we have done that just a few times. I would like to do that a few hundred times to actually be sure that we are fine with that. And now actually becoming why I'm talking actually all about that. I mean, there's lots of possible applications for oil and gas. Originally, I worked actually, I mentioned at some point at Autonomous EOSL, and there was iceberg monitor was one topic. I mean, that definitely can do our system do. I mean, it can be not just necessarily mounted on oil rig, it can be also on a supply ship. So, I mean, we can really quickly search with that drone without having anybody really be trained on the drone system to do actually search for icebergs and or support iceberg towing operations. There was also some ideas from people I talked in the oil and gas industry, weather monitoring, and in that case, it's weather monitoring really for the extreme short time, so that the drone takes off automatically, goes in the direction where the wind comes, where the fog already comes in, and that you actually have an idea, okay, when there will be a hole in the fog, that your helicopter might be able to land actually in that, while that hole is there for just a few minutes, which is definitely, and you can coordinate it possibly. Also, oil spill monitoring, gas leak detection. We can also equip our system easily with different kind of sensors. We have a little Linux computer on board where we can really easily integrate new sensors as long as they're not too heavy. And we even work, as I mentioned before, we're working on versions of the drone system, which will be actually even bigger. One big topic is actually, and that's where the focus will be at the moment at least, inspection and predictive maintenance, which can result from that. So we will, that's the aim at least, monitor the whole structure, so making a 3D model, monitor the changes, or what we're also thinking about putting some AI edit or machine vision better said, to actually identify rust spots, identify probably also too cold or something where you see that purity applications, which I think here in the waters of Newfoundland is not really that issue, but in other parts of the world, that might be certainly something where you want to have regularly some drone 24/7 possibly. If you have multiple drone systems of that, we can actually have 24/7 one in the air to patrol around the oil rig and make sure that nobody is who is not welcome actually gets access to the rig. Also, search and rescue. I mean, I mentioned before, and that I actually just talked recently with some Coast Guard people and Navy people. Also, man overboard is an issue where it's where our system could be the current system even could be really well used, because we have just 4 seconds till we're in the air. So anybody who gets overboard and is noticed can be have somebody have a spot already on it within 4 seconds, and that's a lot's worth, especially if we're talking about strong currents, or if something like a boat or ship is moving quite quickly. Yes. So now we're getting more on the processing side. So what you here see is a test with the drone. I did hold it in the hand in the garage. We didn't fly it in that case, but we would like to actually do that in outside in an industrial environment, where it automatically creates a 3D model of the environment while it's moving around. And I can show you also next one. And that 3D model can be used actually then to compare changes over the time. That's the finished 3D model, not cleaned up, so that's right as it is. You see on the outside there's some things not super clean. That's normal for things like this, because almost the times you see actually 3D models manually cleaned up. In that case, we actually just to show how relative clean. The whole thing is we did by intention nothing, no modifications at all. If you're not used to that kind of 3D environment, they might look a bit not as well, but you can actually see quite good actually things. So to the interfaces, we're coming a bit oil and gas is for us a bit new. That's why the interfaces might be not as familiar for you in that case. And when we also, I mean, what you see on the left bottom, the thing is a touchscreen where you can actually interface the drone system and tell it what it needs to do. You can define waypoints. You can define different kind of missions actually, which include waypoints or there. That's the standard what any kind of drone system can do, which we have also included in the thing, whereas the mission things is a bit above what that stuff does. The next thing is the manual override, which is basically what normally is the normal radio control, what you see when the people standing there and controlling their drone. We have actually modified that, and that can be also in remote operations used anywhere from the world as long as you have the interface, right? And we use actually a standard 3D mouse, which we might know from 3D CAD constructions, and control the drone manually response. And so if you, for example, pull up the mouse, then the drone goes up. If you push the mouse forward, the drone goes forward. If you rotate the mouse, it rotates. So it's really intuitive using, and that you really don't need much training. What we're also thinking about is integrating our whole system into VR and AR environment. That you actually, for example, that 3D model, what you just saw now, is actually integrated, because you don't see really the 3D model itself. I mean, yes, in the video, if you move it around, you see that it's the model itself is 3D, but it's kind of showing a 3D on a 2D thing. It doesn't really make sense. As soon as you integrate that with virtual environment or augmented reality, then you can actually have that 3D effect really good. And if you then overlay on top of that 3D environment thermal camera information and other information on top of it, which we might actually mark objects which has been identified by objects, then by machine vision, then you get a much better idea of what's going on and how it's going on, and you can actually feel yourself as you would be actually standing there, or sometimes in the case which is a bit more scary, that you're actually hovering somewhere in the air above on the side of a tower. Yeah, on the top right, you see actually an image that's more for military purposes, where actually the drone has identified a person and actually put the information about the person, the location, and other possible information about the person what it has identified into a map and visualize it there. I mean, in this case, it's a 3D map, but actually we'll go back to, okay, here's actually a slide about it. What you see here in the bottom video is the drone is actually following a person and provides the information about that person in the map. That is done with machine vision as well. It's easy to do actually. And once the person is identified as a person, it can be location estimated, because we know the location of the drone itself. We know where the camera is pointing to roughly. And with that actually, and you might also lose some methods, or you actually integrate some filters, some, I would say almost AI, and then create actually an updated image all the time of the situational awareness. You see it in the video tiny bit moving, because the scale is a bit different, so that's not moving as fast as the person is running actually. Oh, it appears not moving fast. It is actually moving fast. Accomplishments. I think we mentioned that before. Most of the staff, some is in the military staff, we have invested, and that's actually most of the time and money what I'm invested into the company. And there we also already at the end. So I would say we're ready for questions.
Oh, thank you, Armin. This is such a delightful presentation. You know, it was, you said it a lot throughout the presentation. Oh, this is easy to do. This is easy to do. I don't think you give enough credit, but the automation and integration that you're using within your platform. I'll start it off. There was a question that came through, and I got a couple myself, but I'll start with the one from the audience. And please feel free, anybody else that is listening in, to, if you got questions, put them into Q&A. So one question came from Ray Dalton, and this comes back to the, oil and gas and iceberg questions. If placed on a vessel, is there limitations due to the movement of the vessel, such as pitch and yaw and roll, that may affect your launch and recovery?
Yes, there's certainly limitations. We don't know there's limitations yet. We haven't done really those tests yet, but we will definitely do that. And that's actually one of the reasons why we're saying actually we will build a bigger system that will also incorporate a bigger docking station, which has actually the ability to some extent compensate for that motion. And also due to that it's bigger, it actually allows also some more margin for the movement actually more. So yes, there are limitations. We don't know them, but we expect them. I mean, everything has limitations. I mean, even a Navy helicopter can't land on a ship all the time. They have also their limitations. So that's the fact of reality. And in some cases, there's actually, and that might be actually really the important part, we have much less restrictions regarding takeoff. So if something like says really in adverse weather conditions, somebody gets overboard and you need somebody, the drone in the air, I mean, that's where you really need it when stuff goes wrong, then the drone can certainly go up. You most likely, or maybe not getting the drone back, but I mean, to save it alive, I think that's worth it. So I hope that answers your question.
So on that point, I think you did answer well. As to be determined, but that's where the development is. But on your point of sending it off and not expecting it to return on harsh conditions for man overboard, is that information then live streamed back to the operator? I know you showed a lot of embedded videos on that, and you questioned whether or not, from your perspective, that was embedded after the fact for presentation purposes. But can the operator on the rig or everything like that get live stream of that information?
Okay, I should have said that while the videos. No, that's actually not for the operator. Just that's not in Aftermath all put together. Those videos, they're actually all just filmed off the screen while the whole thing is going on. So they're actually yes, you have all the information available and with I'm saying with 200 milliseconds delay. That's roughly what the video stream decrypting and encrypting takes, and that's what you have there. So there's pretty much no delay at all for human at least. Yes, you have that all.
All right, perfect.
That's a cool system. Yeah, I mean, I know actually, just to go in that question deeper, I know there's a lot of, and actually that might actually forgot completely to mention it. So lots of companies buy lots of stuff off the shelf or assemble some stuff together and put a drone system together, might build some parts themselves. So we're building the drone completely by ourselves, completely from scratch up. That's our design, that's our patent. Nobody else has built exactly a drone like this. There is a few in the military field in the past, which has been somewhat successful, somewhat not. And also docking station and all that, we built it all ourselves here in Newfoundland. That said, it's a lot of work, but it also gives us the ability to integrate everything really nicely in together. So we don't have some multiple radios on the drone. We have one radio, which comes out of the military perspective. It has really high power. It's completely encrypted, but it also has the ability to actually stream all the information what we're collecting on the drone in live without any delay, pretty much to the user. So there's no frickling stuff. Oh, we put another sensor on and have a separate radio for that and all that stuff. That's all fully nicely integrated in a clean solution.
All right, perfect. I got another one coming from the audience. And before I get to that, I just want to reshare some of the videos that Armin had within his presentation. I'm putting links to it in our chat function so that you can go into YouTube and get a look, to have a closer look at some of the videos that Armin presented during this video. So going to the new question here, the horizontal flight mode is very cool and advantageous capability. Has it been tested? And if so, do you have footage that you can share?
Who is asking that? So I think I don't even mention it. It's just somewhere mentioned in the slide, really tiny there. Yes, we had, and there's no reason why I'm not showing really much videos about it. We have actually demonstrated the capability of the transition into the horizontal flight as a part of a project with the Department of National Defense. So we're keeping that a bit back because we don't want to wake up our competition too early. And I think for lots of oil and gas applications, except for search and rescue applications, it might be not relevant really. But yes, we have a video of it. It's a relatively short one. And we have done it just a few times just to demonstrate the capability. The issue is with that capability, and we're working actually on a different solution, even less complex a bit, is that on that small drone, what we have right now, the mechanics of the wing and all that stuff actually pretty much eats up all the payload capacity. So yes, we have a drone which can fly, can transition in horizontal flight and transition actually back to, but without having a camera at least or some other sensors on board, there's no use at all. So in a bigger version, that will be definitely possible, and that will actually, that's one of the reasons why we aiming to build a bigger version, not necessarily just to increase actually the payload capacity in general, but that's also a reason to actually have bigger sensors and more sensors on board, but also to allow possibly, depending on the applications needs, having that capability also going horizontal flight.
All right, I got, there's a question that came in through the audience, and I'm going to add a little bit tied in with what you just said. So for my part is, right now, what is your payload limitation when it comes to, you got your camera and your battery, but what other sensors have you actually used and tested on it? And then the question that's I'm leading into from the audience is, there are other digital solutions out there to, to schedule and perform inspections on oil platforms. Have you considered integrating or partnering with any of them to trigger the drone, perform the inspection, and return the results?
Okay, that's two lengthy questions.
I added one part about the payload, and then the second one is,
yeah. So the payload capacity. Let's
says,
answer that first quickly. Yeah, so the payload capacity is around 500 grams. But that said, I mean, it's not that we deliver the drone just to somebody and you can integrate stuff. Since we mentioned before, it's all integrated in our case. So we will integrate the payload for them. And we have tested different kind of sensors. So thermal camera, the normal EO camera, what you have seen in the video. We have stereo cameras for actually creating 3D models on ad hoc, not with photogrammetry, with stereo part. We have also integrated, I think one was CO2 sensors, which is obviously not that interesting in most cases, I would say. But methane or other gas sensors would be certainly possible to integrate. There's a lot of possibilities. I mean, later in the small version that has the 500 gram, the bigger version, we're talking about a few kilograms payload capacity. So there we can certainly integrate laser scanners and other more weight things. But also that said, I mean, often we get questions, hey, we would like to have a sensor integrated with that and that capabilities. And we say, or that specific sensor. And then we look at the data sheet and say, actually, we can actually get you a sensor which weighs a fraction of the weight of that. We can integrate that one actually, and has exactly the same performance for your use case. So there's a lot of cases where we actually can integrate stuff where people might say, yeah, that's too less. That's why the payload capacity question is always a really tricky one, I would say. So to the other questions, no, we have talked loosely about some stuff, and we're certainly, we're just starting with the oil and gas field. So we're really not that experienced. If there's somebody out there who thinks, hey, that would be a great system to integrate with, and actually, a matter of fact, from that Hector team, there's an outsourced team, actually, a company actually was outsourced. And we're actually thinking about possibly, which if it would be more advanced, we would actually integrate, possibly to integrate with them. But if there's somebody out there who has an idea, if there's somebody out there who has really interest to, where thinks it would work well together, please approach us. I'm really happy to work together with anybody when it makes sense.
All right, excellent token there. I'm going to do one last question from the audience here. There's a question here about how energy efficient is your UAV compared to others?
Okay, that's kind of energy efficient. What? Okay, let's say your car is 30% energy efficient. No, actually, so the question is not really about efficiency. I mean, if you're aiming for that, yes, we have 15 minutes flight time. Compared to some other drones, that's a bit low. So our efficiency regarding hover flight is not as good as other drones, but that also means we are more robust against turbulences and strong winds, actually, because and that's not to go in too deep into the whole thing, you can get the same thrust by making the rotor diameter smaller, but increasing the speed actually of the whole thing. With that, you're getting the same thrust, but you actually need more power in that case. So you're getting, to answer that question, you're getting less efficient. But it also means your difference between the wind and the thrust, the air coming out of the thing, which basically creates the thrust, is suddenly not anymore is much bigger. So then if your wind gust comes, you're actually losing much less on weight. So it's really, in most cases, our drone system doesn't really matter the efficiency. I mean, you're not driving a car because of efficiency in most cases. It's just because it does the job, and that's what counts. And yes, we would like to have our system a bit more efficient, but that's inherent in that system. And we gain quite some efficiency through the duct itself. There's some aerodynamic tricks what we're already doing, and so we're getting some efficiency back. But again, in most cases, the efficiency is not what you're looking for. It's get a job done.
All right. Thank you for that. And, you know, it's a pleasure talking to you and working with you over these last couple of weeks. It's been a pleasure of seeing how your company has come along over the past few years. Personally, I started dealing with you back when you were AS Works in a different capacity of my life. But it's great to see that you're constantly evolving. You're constantly, you know, challenging what is possible when it comes to UAVs and UASs. And I really look forward to your next chapter on getting some of these out there on platforms and on vessels. And it's going to be really exciting to see StrobelTEK you know, as a part of the solution for the field of the future. So appreciate all the effort that you've done into coming here today and speaking. And we had a great response from the audience, you know, good dialogue back and forth. So thank you very much. And with that, I'd like to say thank you to all the audience for showing up. And we have one more webinar coming up on remote operations next week, this time by ExxonMobil. So please look out for that invitations through events at TechNL. And to you all, thank you and have a great day. Cheers.
Thank you for having me. And I'm really excited also about the future.
See you, everyone.